Hi, everyone.
Hi. I
Oh,
think we'll get started in a few minutes, just to let people pour in.
there's so many people here, Christian. So big.
Yeah, I think we got a lot more traction on Twitter, especially with this one. Nicole, I mean, mindful of time, whenever you want to get started, I think we can go ahead.
Ready. I'll jump in and then we can just admit people as they join, just since I know we have a lot of material that we want to cover tonight. So first, I just want to say hello and welcome to everyone here. And we're really excited to have you at our beginner workshop on using Git and GitHub with R and RStudio. I am Nicole Swartwood, and I work as a research analyst in the Global Health and Population Department at the Harvard School of Public Health. And I'll pass it off to my co-presenter, Christian, to introduce himself and to make a few announcements before we get started.
Hi, everybody. I'm Christian Testa. I'm a statistical analyst at the Harvard School of Public Health. Nicole and I used to work together, and it's been a delight working with her, organizing these R user groups. And Gwen used to be one of our organizers too. So shout out to Gwen. I do have a couple of announcements. September 29th, tentatively, we'll have another R user group meeting, and that will be some kind of tips and tricks to really make your ggplot data visualizations that much more professional. So it will be taking what we've already talked about in some of the intro to ggplot lectures that we've done, and really expanding on that to include some tips and tricks and tools that will help you make your visualizations more professional and more communicative. And then we want to, as always, call for organizers. So if you're affiliated with Harvard formally and you're interested in helping us organize these meetings, definitely reach out to us. We would love to have more people on board to help us organize these meetings. So please reach out. And finally, we're always looking for people to follow us on our Twitter. And if you're affiliated with Harvard, to join the Slack channel, our user group Slack channel on the Harvard Data Science Initiative Slack. So if you would like to communicate with us, definitely hop on there and join. Okay, back to Nicole.
Thank you so much, Christian. So I just wanted to orient people. So I'll begin by walking us through a slideshow for the first half to 2/3 of the workshop, and then Christian will be taking over with a live demonstration of some of the concepts that we'll have discussed up to that point. We ask that you please hold all your questions into the end of the presentation and demonstration. Yeah, we really don't want you to get lost throughout the presentation. So if you do miss something or you just get confused, I encourage you to pop your question in the chat, and Christian will attempt to answer it as I go through the slides. And with that, let's jump in. Great. So I wanted to start today's presentation with a brief discussion on why you should consider using version control in your development workflow. First, version control makes coordinating across computers easier, coordinating your files across computers easier. This can be helpful in circumstances where you're working on your code across machines, or when an outside person, such as your supervisor, may want to review your code. You or they can simply view your script through the version control system, as opposed to passing scripts and probably several dependencies back and forth through email or Dropbox or some other file share system. Version control also keeps a clean history of your code's evolution. Instead of needing to develop a plethora of unique file names and messy system of suffixes to distinguish different versions of your code, version control allows you to document these changes under the same consistent file name over time. Version control also gives you an opportunity to ask yourself, am I really ready to make these changes before you commit them to your repository? Or do we really, or allows you to think if there are additional tests or features you'd like to build in before making those changes formal. And finally, version control streamlines the process of reviewing code changes made by others. Now that I've hopefully convinced you that using version control is a good idea, I'll just briefly mention why Git is a good resource for version control. One of the predominant reasons to use Git is its universality. A recent developer survey at Stack Overflow estimates that nearly 94% of developers are using Git. This incredible user base means there's a myriad of resources for getting started and troubleshooting in Git. It also means that there's easy compatibility across development teams and projects, as the majority of developers are speaking the same language. Git is an open source version control system. It stores code and its history in a specific place known as a repository. Each revision to the code is added to the repository through a commit process. The defining feature of Git, as opposed to other version control systems, is its branching schema, which allows development or test code to remain separate from the main code base until it's complete. Git also allows you to push and pull code from remote servers. I'll now transition to a brief discussion of GitHub, which, while it connects and works with Git, is a separate tool. And if there's one thing that you walk away with today's talk knowing, I hope it's that Git and GitHub are different, since this is a very common misconception. GitHub is a website and an online service that allows you to host your Git repositories. It also has features to enhance your workflows, such as issue tracking and automated project workflows. It is also a collaborative space where you can publicize your code, review others' code, coordinate developer teams, and perform project management tasks. GitHub is a tool with a wide feature base, so I encourage you to read more about it and some of the more detailed services that they provide. And if there's interest, perhaps we could have a follow-up workshop on how to leverage GitHub in your professional development. Before jumping into setting up Git and GitHub, I thought it would be pertinent to discuss a few things you may want to ruminate on before diving into your version control setup. The first of these two are more in the vein of personal reflection, while the latter two are more logistical in nature. Often when we try to incorporate a new tool into our workflow, it can be easy to just rush into the setup and attempt to learn everything as we go. And while this is totally an option with Git and GitHub, I would recommend instead taking a bit of time to identify which features of these tools you are most interested in leveraging in your workflow. Identifying these features early will allow you to learn more about them and design your repositories in a way that best utilizes these moving forward. Similarly, it can be incredibly useful to look through successful repositories to understand their structure, workflows, and syntax, then incorporate that knowledge down into your repositories. On the other hand, there are a few logistical concerns you may need to consider when setting up your version control. First, if you are working with confidential data or code requiring high security, you should talk to your local IT department to determine your best path forward with version control. Additionally, institutions may have their own Git server, or your workplace may have an organization on GitHub that they want to have all their code associated with, so you may need to connect your repository to that account. Overall, the best advice is to communicate with your team about logistics before setting up a professional repository. At this point, I'll transition to a brief step-by-step walkthrough of some of the steps for setting up Git and GitHub on your machine. First, you'll need to install Git, and this process is operating system specific. So it would take far too much time for us to walk through each of the different permutations of these installations this evening. There are a number of great tutorials online, and often Git can be installed with just a few simple commands at the terminal. We highly recommend this chapter of Happy Git with R, which walks through several options for each of the operating systems. After you have Git installed, you'll need to introduce yourself to it through configuration. You can configure Git by running a few Git config commands in the terminal window, and those are listed here on this slide. You'll need to enter a username and an email, and you'll want to make sure that you use the same name and email address that you'll be using with GitHub during that setup. Once you've run these two configuration commands, you can check that they were successful by using the list option as seen on line 3 here. Once you have Git installed and configured, you'll now want to set up a GitHub account. To do this, you can navigate to github.com/join, where you'll enter a username and the same email address that you used for Git. Happy Git with R also has a list of advice here on how to best create your username, but overall, you want it to be durable, professional, and easily associated with you moving forward. We highly recommend setting up a secure shell or SSH key for authentication with GitHub. This allows your computer to be automatically authenticated when you are trying to communicate with GitHub from your machine. Again, you can follow instructions online or from Happy Git with R to set this up. So now you hopefully have Git and GitHub set up and you're ready to create your first repository. Congratulations. There are a number of different ways to set up a local repository, so I just wanted to take a moment to walk through each of them. You'll notice I mentioned that these are options for a local repository, which means after the setup, we will be version controlling with Git, but not using GitHub, a connection that needs to be made in a separate step, which I will cover after walking through each of these local options. For the first two options, we will be using the command line to create a repository. In the first case, on the left, we are in a situation where we have an existing code base contained in a directory called new directory. We want to connect to Git. In this situation, we simply navigate to within that directory, type the Git Init command, which will initialize a Git repository connected with the directory. If we then explore the files using ls-la, which shows hidden files, we'll see that there's a Git folder created in this directory, letting us confirm that our setup was successful. In the other option on the right-hand side, we are creating our Git repository without any associated code. In order to do this, we navigate to where we want our repository stored, and again type Git Init, but this time we include what we want our repository name to be in quotes, as seen here with quote repo name. And again, we can confirm our repository creation was successful by looking for that .git folder in the directory. Now that we've seen how to create repositories on the command line, let's see how we can use RStudio with Git. In order to use RStudio to create a new Git repository, we must create a project or package. To do this, you can navigate to File, then New Project, which will display a pop-up in the New Project wizard. Here you will enter your directory name and where you want the project to be stored. And in order to use Git with this new project, you must select Create a New Git Repository to inform RStudio that you want to use Git with this project. If you'd like to configure RStudio to use version control with an existing R project, you can also do that. For this workflow, you will navigate to Tools, then to Project Options, then select the Git SVN tab, and then select Git from the version control system dropdown. It is important to note that this will only work if you're working in an R project, not just a directory of code. After letting RStudio know you're going to be using Git with your project, it'll add a Git tab in your environment history panel. This panel is a point-and-click interface that allows you to perform some basic steps of the Git and GitHub workflow, such as reviewing and staging changes, writing, pushing, and pulling commits, and creating and navigating branches. If you're unclear about any of those steps, don't worry. We'll be walking through them in subsequent slides and in Christian's demonstration. Once you have a local Git repository, you'll also need to create a remote repository on GitHub and connect the local to the remote so you can communicate between the two. In order to create a GitHub repository, simply navigate to github.com, log in with the account that you created earlier, and then select the green New button at the top left of your homepage. This button will direct you to a form that will ask you to name your repository and where you would, where you should enter the same name as your local repository, and then select a few other options, such as if you want your code to be public or private, or whether you'd like to initialize your repository with a few files. Once you have all your information entered, you'll click Repository, click Create Repository. Now that you have a local and a remote repository, you need to connect them so they communicate the changes in your code between them. In order to connect these using the command line, you want to navigate into your repository and run the following 3 lines of code. The first of these is git remote add origin, and then the URL of your remote branch. And this just lets Git on your local computer know where your GitHub repository is. The second command here is somewhat optional and is necessary because GitHub has switched their main or default branch to be called main, whereas Git will still default to master in most cases. And so the second command is just renaming that branch. And then finally, you'll perform this command git push -u origin branch name, where we push these changes to the remote repository. It's very important that you include the -u here, which is shorthand for the set upstream option, or this will be rejected. And this sets the default remote branch for the current local branch. It sounds much more complicated than it is, and it usually works really straightforwardly. And once you've done these steps, your local and your remote repositories are connected and the doors to Git and GitHub are open. Great. Now that you have your new repository, I highly recommend taking the time right here at the beginning to create a bit of documentation describing your repository. Each repository should have a file devoted to documentation of the code base as a whole, which is traditionally called a README and is created in a markdown language. This file should include an overall description of the code base, such as this repository contains the scripts for the specific data analysis, or this package serves as a novel method to estimate some unique measure. As you further develop your code base, this file should grow along with it and should eventually show how to install and use your package and scripts. I know that documentation can often feel daunting, but it is a critical point for successful code sharing, and feel free to start small and document as you develop to make it seem a less hefty task. Here we see the basic workflow with Git, which is as simple as a 3-step process. You make changes to your files, you add those changes to Git staging area, then commit these changes to your repository. For some workflows, specifically when you are working on a repository by yourself, you may find that you rarely need commands beyond these 3 steps. This is the core of Git. I'll now walk through a few key Git commands that are vital for efficient, productive workflows. The first of these is called Git Status, which, as the name suggests, will display the current state or status of your working directory. In the first of these images on the top, we see that if we run Git Status in our repository repo name, we see that it's on its master or main branch, has no files changed and no commits. In the second image, we see that if we run it in this other repository new directory that we created earlier, it still has no commits, but we have 2 files that have been edited, but not committed or staged. The RStudio Git panel displays much of this information as well, so if you're less comfortable with the command line, you can keep an eye on that tab to understand the status of your repository. I highly recommend running Git Status or inspecting your Git panel when you sit down to your repository to make code modifications, understanding the branch you're on and what changes have and haven't been committed, or exploring if remote changes have been made by others can prevent messy code conflicts in the future. Once you have inspected the status of your repository, you will most likely perform some changes to your existing files or create new ones. At some point, you'll want to add these changes to Git staging area, staging environment or index. By staging the changes, we let Git know that what changes we are looking to commit. To stage your change, you'll run git add and then followed by the file name in the command line, which will stage your file for commit. In this image on the right, we see that I have added the Readme file to the staging area and is now displayed under a heading, changes to be committed, with its name in green. If we want to stage files using the RStudio GUI, we will need to click the checkbox on the far left of the Git panel, which will stage the file, which is indicated with a check mark in the box to the left side of the file name. Once we have our changes staged, we can then formalize these changes by recording or committing them to the repository from the index. When you commit your changes, they become part of the history of your code's evolution, which can be used by others to better understand the development process, or for you to troubleshoot your code if you need in the future. In order to commit your code, you will need to craft a commit message, which we will walk through on the next 2 slides. Here, however, I want to point out that you can commit your changes by running git commit or git commit -m followed by your commit message on the command line. In order to commit code from RStudio, first click commit on the Git tab, which will launch a pop-up, which will allow you to review your changes, check that the files you wish to commit are staged. Once you are happy with these, you will enter your commit message in the box on the upper right, and then click commit here. Since commit messages are a historical record of your code, it is important that these messages are optimized in a way that makes them easily understood and able to efficiently convey information. Some key tips for your commits are on this slide, with recommendations on grammar rules, a suggestion of using the imperative mood, keeping your first line under 50 characters, as well as just encouraging you to be direct. It can also be useful to have a consistent set of words that describe changes, such as update, add, or bug fix, which makes scanning through a commit history much easier. In order to develop thoughtful commits that can be the most useful in the future, you should really consider a couple of these following questions, such as why have I made these changes and what effect will these changes have? And why was the change needed and what are the changes in reference to? You really just want to delve into what these changes represent for your code moving forward. You can also find more information at this link here. If sifting through detailed commit messages to glean the history of a repository sounds exhausting to you, you are not alone. In order to make our code history more accessible, it's highly recommended to also include a changelog with your repository, which will keep track of a curated, informative history of your project's updates. This website listed here, keepachangelog.com, is an excellent resource, which even has templates for you to jumpstart your changelog, so please check it out. Once you have committed your changes with the amazing commit messages, I know everyone is going to go right after this, you need to let the remote repository on GitHub know that you've made these changes. In order to do this, we will push the changes to the remote repository. From the command line, you will enter git push origin followed by the branch name on the local repository. Because of the initial setup we performed between our local and remote repository, GitHub will automatically associate the local with the correct remote repository. These changes will now be online and viewable in your repository. In order to push changes in the RStudio window, we simply select the push button on the top right-hand corner of the pop-up we used for our commit message, or on the center of the Git panel. And RStudio is really great because it'll give you this notification on that pop-up when your branch is ahead of the remote by any commits. Once we have pushed our changes, we have completed not only the basic 3-step workflow, once we've pushed our changes, we have completed not only the 3-step workflow I discussed earlier, but we've also communicated that to the remote branch. However, there are still a couple of key commands to mention that can be useful even without collaboration. The first of these is git fetch, which downloads objects and histories from another, often a remote repository. I mentioned Git Status before, which can let us know if we have changes locally. However, if there are remote changes, these are unknown locally until we fetch them. After we run git fetch, we can see that we are now notified of the existence of remote changes with this message here that lets us know that the branch is behind the origin made by one commit. To further inspect them, we'll use another command. And before moving on, I'll just mention that there are additional uses of git fetch that are beyond the scope of this talk, but please feel free to read more about those. Once we see that there is a difference between our local and the remote branch, we can inspect these changes by using the Git Diff function. By running Git Diff with the summary option, we see that the changes between the two branches, while if we are only interested in a specific file, we can just specify that in the command as seen here in the second line. And in these first two examples, we are specifying fetch head because we want to compare the current state or head of the remote repository to what we have locally. However, we could use Git Diff to compare across different branches by specifying 2 branch names separated by 2 dots. Finally, we can simply see the difference between current and modified version of our files and the version in the last commit by simply running Git Diff with or without specific file names. This command is incredibly versatile, and I encourage you to read more about it. Using RStudio, unfortunately, we are limited to only the last case, which shows our local changes. However, the interface makes it incredibly easy to see where and what changes have been made, which can make double checking your code more straightforward. Suppose we see these changes and we want to incorporate them into our code. The first step here is to pull the changes down into our local repository. Git pull will fetch and integrate code from one repository to another as long as there is no conflicts between the 2 code bases. If there are conflicts, there are ways to manage these, but again, that is beyond the scope of today's workshop. In order to retrieve these changes from the remote branch, we simply use git pull in the command line. In RStudio, we can use the pull button on the Git panel. Up to this point, we have seen some of the basics of working with Git and GitHub, but now I would like to pivot to an introduction to using these tools for collaboration. As we discussed at the beginning of this talk, GitHub can be a valuable tool for development teams, but it's important that the features provided by GitHub are used in a way to make this process smooth for all involved. For example, when multiple developers are working on the same shared repository, decisions will need to be made on how to implement code changes. In most situations, when a code is undergoing small changes, especially those that may affect only one script or process, it can be reasonable to work on the same branch. However, when changes expand in scope, it is much preferred to separate this development workflow from the stable code base, which can be done through branching the code. Additionally, if you see a repository that you'd like to work on, but you're not a member of its development team, you can clone this repository into your account by forking it. Forking allows you to have a completely separate development stream from the original repository. In both of these cases, there's a mechanism, namely pull requests, that allow you to submit these changes for incorporation into the main stable code base once those changes have been finalized and tested. When using Git or Git in GitHub for collaboration, remember that communication is key. Always discuss your workflow processes, write thorough documentation, and draft clear commits and pull requests in order to avoid any issues moving forward. Now that I've introduced how workflows may work with collaboration, I want to walk through a few of these key, quote, next level commands. The first of these is the creation of branches on a repository. Branches serve as a pointer to your change and are a key development tool. When creating bug fixes or new features, it's especially useful to protect the stable code from the volatility that often comes from these processes. In order to create a new branch on the command line, simply type git checkout -b, where the B stands for branch, followed by the new branch name. This will both create a new branch and navigate your development to be on this branch. In order to switch between branches, you can simply use git checkout followed by the branch name you'd like to navigate to. On RStudio, to create a new branch, you click these connected purple boxes on the right side of the Git tab, resulting in a pop-up prompting you to add your new branch name. Once development has been completed on a branch, you may want to incorporate those changes back into your main branch. In order to accomplish this, you will merge the changes from your development branch into the main branch. This is done by first checking out the branch that you want to merge your changes into, then running git merge followed by the branch that has the changes you want to merge. Here we see that merging our changes from the great user branch into the main branch added a new file into the main branch repository, namely print-hello-user.r. Unfortunately, the RStudio Git tab does not have merge functionality, but if you do prefer a graphical interface, you can use GitHub to evaluate the viability of a merge and complete the process there. As I mentioned before, Git forks also allow development without affecting the main project. In addition to being useful for external developers, they can also serve as a way to develop intentionally separate versions of a project in parallel, which you may have no intention of merging together in the future. To fork a repository, you can navigate to a repository's homepage on GitHub and select fork, and create new fork from the dropdown. Once you have finished your development on a branch or fork, you may want to propose that these changes are incorporated into the main branch of a repository. In order to do so, you would submit a pull request to the repository's maintainer. The pull request alerts the owner that changes have been made and gives them a chance to review and test the code before adding it to the repository. As with commit messages, optimizing the language in your pull request is crucial, and there are resources that discuss this at length, such as this GitHub blog that I've mentioned here, or that I've linked here. I wanted to end the presentation with a couple of commands that I find especially useful and wish I'd known about sooner in my use of Git and GitHub. These both are useful features for maintaining a clean code history. The first of these commands is Git Stash, which is useful in situations where you may need to navigate between branches mid-development. For example, you may need to switch from your feature development branch to address an immediate customer concern. Instead of having to commit a half-developed feature, Git Stash allows us to stash these changes away temporarily, switch branches, and not lose our changes. In order to stash changes, you simply run Git Stash on the command line from within your repository. You can then check out another branch, make changes, and commit them. At this point, if you're ready to return to your branch with stash changes, you simply check out that branch and then run git stash pop to have those changes restored to your environment. Another useful command for a clear commit history is Git Squash, which combines several existing commits into a single commit. Git Squash can be especially useful when incorporating those development branches back into your main branch, as these branches may have chaotic, difficult to understand commits that are testing different approaches or methods to solving a problem. While squashing commits can clarify a history, it is recommended that you use them sparingly and focus instead on having clear commits throughout the development in a regularly updated changelog. I also want to very briefly mention that all Git commands have option flags, of which I've listed a couple examples here. Information on these command flags can be found on the documentations for the command or by running the command or this option here, help, after any specific command in the terminal. I'll now close with a bit of hard-won advice. If you aren't exactly sure about the Git procedure you're about to do, try it on a dummy repository. This can give you the confidence in the changes you're about to make to your Git repositories, as opposed to just trying to guess whether or not the Git commands you're thinking of will do what you want. This is especially useful when you're attempting to perform more complicated operations, such as rewriting commit history or removing files retroactively, neither of which that we touched on today, but we would be happy to touch on in a further workshop if there's interest. Secondly, if you do try a new command and it doesn't work like it intended and you feel like something or everything is broken, I just highly encourage you to try and stay calm. It can be incredibly anxiety inducing when you think your repository is behaving in a way that you don't understand, but there's almost always a fix. Remember that nearly 94% of developers are using Git, and most likely somewhere else has made the same mistake, and there's some resource to guide you through repairing it. Here we just have a few additional resources to check out on your own time. And with that, I thank y'all so much for your attention, and I'll pass it to Christian for the live demonstration. If during the demonstration you have any questions, we ask you to hold on to them to the end of the demonstration. But again, if you get lost at any point, pop your clarifying question in the chat and I will attempt to answer. Thanks.
Thank you so much, Nicole. What a wonderful presentation. I will have to do my best to follow it up with an equally impressive live demonstration. So if I go ahead and share my screen, I'll go ahead and get started with live demonstration. And what I want to emphasize in my live demonstration is mostly the individual-based workflow. We talked a bit about collaboration with GitHub, but as this workshop is really oriented towards beginners, we want to make sure that those fundamentals are down pat first. So one of the things that I think is useful for me to talk about first is, once you've set up your GitHub account, there's some features of GitHub that I want to alert you to. So GitHub is a lot like social media for developers. And so once you start following developers, it provides you this nice interface to stay up to date with their work. And I don't know that came through with all of the technical details that we were talking about earlier. And the other thing that I really want to alert you to is the fact that it, as a kind of social media, you can develop your own personal portfolio on here. And so, for example, this is mine. I have some, specific articles that I've highlighted, as well as some code-based projects that I've highlighted. And it's interesting to be able to see your peers and their developers' contributions in their work. So I just wanted to alert you to the existence of these features of GitHub so that you would have some more compelling reasons to join. But I'll go ahead and get started, and I'll make a new repository. The example that I've chosen today to show you guys is to just make a really simple script that will continuously update with a few different examples that show some different approaches to computing the Fibonacci numbers. I'm just going to name this an example project to compute the Fibonacci numbers and demonstrating Git and GitHub functionality. So I'll make this repository, and then what I'll go ahead and do is I'll make a new project in RStudio, just like you all are already familiar with how to do. And like Nicole was saying, I'll initialize that as a Git repository and I'll just name it Fibonacci. And so the first thing I'm going to do to connect these two is I'm going to go over to this terminal window. And let me just zoom my screen in a little bit so that everybody can see it. You'll see that it has this, that I have this Git window automatically come up, and that's because I initialized it as a Git repository. And indeed, if I do Git Status, you'll see that it's alerting me to the fact that I have no commits yet. I'm on the branch master, which is a bit outdated terminology. Typically, everything in the Git world has been moving to using the main as the main branch instead of master. And so you'll see that in the advice that GitHub gives you, they immediately correct that. So these three commands will more or less get us set up. So I'm going to just run the first two for right now, actually just the first one to add the origin. And so if I, for example, look at the config, you'll see that now the remote origin URL is git at github.com and then my username and Fibonacci.git. And then I am going to need to add some files so that I'm able to commit. So I'll add the Git Ignore. Git add Git Ignore. And I could also do that. Actually, let me do that with the RStudio pane over here. So if I, for example, select that, and maybe I'll add this one too. So for example, with these, since I'm not really getting much done here, I might just put an initial commit, and I'll commit that, and I'll close that. I'll follow GitHub's advice here and rename my branch to main, since I also prefer that nomenclature. And then I'll just show you, for example, if I perform git push, it will let you know that this is not set up to track with an upstream branch. Origin here refers to the remote server. So in this case, it's referring to GitHub. So I'll take their advice and I'll run, you could do -u or this -set upstream origin main. And that just is letting it know that I want to push my files to the main branch on GitHub. So now if I go back to where I was on GitHub and I refresh this page, you'll see, just those really boilerplate files have just shown up. So much more work to do. The first thing I'm going to do is I'm going to take some of Nicole's advice and I'm going to start a Readme file. So I'll name that readme.md, and that stands for Markdown. I'm fairly prepared for today's talk. So I actually have a README already written that I want to use here. And I'll paste that in, but I do want to walk through it. So I'm including a title for my talk, for my repository, some expository information. So this is talking about what the Fibonacci numbers are. And in general, your introduction to your repository should describe what mission your code accomplishes. And in particular, this README is documenting the Git commands and processes and the scenario that we're working through. And then there's some details about the setup that we are doing. So now you can see I have changes on this README. So I might as well go ahead and check this and write a commit message to go with it and say add a README here. And then if I push that, I can use this push button. You'll see that it will appear on the GitHub page. So if I refresh this, instead of having that message that was appearing before that said like help other people understand your repository by adding a README, now they actually see my README and it's fairly structured. So all of this structure that is in here in terms of the formatting is in what's called the Markdown language. And I've included a link in here about the Markdown syntax, as well as some articles on how to write a good README. So I'd encourage everybody to check out these articles. I'll put this how to write a good README in the chat. So that's there. And then I'm encouraging everyone to take a look at some successful examples of repositories and READMEs. So, you know, if you go to like the dplyr repository, you'll see that they have this overview and some examples at a really high level, and then, you know, installation instructions, and a lot of information that's really useful to people looking to use their code as a resource. The same thing if you check out the ggplot2 repository, and you'll find lots of good advice in those articles that I linked about what are the good kinds of things you can include in a README. So we just did this. You can either do it on the terminal or you can do it using the Git panel in RStudio, but this is exactly what we just did, adding the README, writing a commit message, and pushing it to GitHub. So now it appears on here, and whenever anybody visits this repository, they'll be met with this really nice presentation of the work instead of just a list of R files or just a list of code files that can be really daunting. Next, I wanted to talk about, you may have noticed, as soon as I set up my repository, this file exists. This is the Git Ignore file. It has a dot in front because it's usually a hidden file. And this is just telling Git and GitHub the files that I want to ignore. So if these files change, Git won't automatically alert me that there are changes in them. And the reason RStudio set me up with these is because, for example, this .r history file is just a history of the commands that I've run. So maybe I don't necessarily want to send that to GitHub. And same thing with these .r data and .r proj user. These are really just kind of hidden files that aren't meaningful to anybody outside the context of my specific RStudio session. So sometimes it's useful to add other files to this. Like on Mac OS, there's always these .ds_store files that pop up that, you know, aren't meaningful for anybody else. They're just a configuration file for Finder to configure how each file folder is displayed. And so definitely not the kind of thing you need to push to GitHub. That's kind of a trivial example, but something else that's really important to put in your Git Ignore are like sensitive data files that you don't want leaving your computer, or really, really large files that shouldn't be pushed to GitHub. Like if you have files that are like 1 gigabyte or 2 gigabytes, maybe those are better off in a database or on an external server than being tracked on Git and GitHub. So I wanted to tell you about the Git Ignore file. You'll see since I added the .ds store, I have a commit. So in the individual kind of workflow, I would just keep making these changes. I might write a commit message to just notate what I did, and I'd push that change. And so now let's go ahead and let me just reference, yeah. So now we're ready to start making subsequent commits. So I'll go ahead and start an R script. I'll name this Fibonacci.r. And I have a scenario in mind that I want us to think about and work through. And we're just going to start with this first example. So the scenario that I have in my head is a kind of a trivial one, but it's one that will help us see an example of code that you iterate on in over time with multiple versions. So the simple example is that maybe your boss says, I want you to write a function for me that produces the nth Fibonacci number, but I only need it to go up to 20. Okay, well, that's easy enough. You might find online that the numbers are just out there. You can go and find them. You don't need to have to worry about how to come up with them. And you know, if you run this function, you know, the first Fibonacci number is 0, the second one is 1. And for those of you who don't know the Fibonacci numbers, a quick introduction. The first two numbers are just defined. It's 0 and then 1. And for all subsequent numbers in the sequence, the nth number is defined as the n-1 and n-2 numbers summed together. So the next number in the sequence is 1, and then 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on and so forth. 3 plus 5 is 8, and so on and so forth. So you can see that the sequence just continuously increases. But here we have a nice method that just has the numbers written down for us. And we can even write some tests. Like I love to see tests. And so in just a really simple script, I might use the assert that library. This is a basic feature of the Fibonacci sequence. And then here I'm asserting in a test that the description that I just gave to you about the Fibonacci numbers should be true for this sequence. So the nth Fibonacci number should be the n-1 plus n-2 numbers. So I can run this test and I got no errors. So the test passed. This looks great. This is like, I've written my code, I've written some tests, I'm feeling confident, I can commit it and I could share it with my boss. So, I could add the first version of the Fibonacci function, and I could commit that. And now I want to show you a few features of GitHub. So, now that I've committed that, you can see that it's here on GitHub. There's some really nice features of GitHub, like you're automatically getting syntax highlighting. There's some things in here that I really like. You can select like specific lines and link people to them. So like if you ever have a problem, you can copy a permalink to a specific line. You can use git blame to find out what commit specific lines were committed in or who wrote them and things like that. So you can see here that it's telling me that this data was written in this commit that I just referenced. And the other thing that I want to show you is if from the main page, if you click on this button where it says 4 commits for me, you can see each of your commits. And so you can see, for example, like in this, all of this stuff in green is stuff that I added. So you can really get a fine-grained perspective on what you've been adding. Okay, so now, you might tell your boss, you might just give them the link to the repository. They might clone the code, they could clone it here, or if they're not familiar with GitHub, you could tell them to download the zip file. I know it's heresy, but for people who don't know the workflow, they might just download the zip file and that would be fine for them. And they could run your code and they would tell you like, okay, this is great. But the stakeholders got back to me. They love your work, but now they want a bunch more. So we'll add a new method. So the next method is to do it recursively. So this is a recursive function where for the first value and the second value, as I mentioned, they're just defined as 0 and 1. And then for all values greater than 3, it returns the n-1 plus the n-2 value. So we can define that function. And then basically we just run the second, the same set of tests, except I'm only going to go up to 40 here because there's a slight issue, which is you might notice that this is kind of taking a long time to get to 40. In fact, I don't even know if it will get to 40. Maybe if we can test it on the first 30 numbers, it will run. And there's a reason for that. That's because a recursive algorithm can tend to go in on itself over and over and over. And if we were to really debug this, we would find that it's calling itself over and over in order to try and calculate the 40th Fibonacci number. Or if I tried to calculate the 50th Fibonacci number or something, I would run into errors. So at this stage, I mean, it's great that my tests are passing, but it's really annoying that I'm not able to calculate larger values of the Fibonacci numbers as fast as I want to, right? So this represents like a real world situation because you might write your code, it might work for some tests, but it might just be really slow or something like, and you need to debug it. And so at this stage, it's, you can commit and say add a recursive version and commit this, push it to GitHub. And then, the same thing, what you might do is to select, you could even link to this section. You can copy a permalink to these lines and share that with your colleagues to say, okay, so I've developed this new recursive method, but it's running really slow. Could you help me debug it? And you might do like all this research, you might ask around, and after a while, you might finally run into a mathematician who can tell you what your mistake was or what your problems are. So I'll add a final method, method 3, which is the exact formula. So even though the Fibonacci sequence is typically defined in terms of a recursive formula, there is an exact formula that can be derived, and it actually makes use of the golden ratio. This is where the golden ratio often comes from. Whatever, I'm not going to say any more about that. But more or less, this represents bringing in your mathematician colleagues or somebody else with domain expertise, because sometimes you might develop a really good prototype of some algorithm, and you need to bring in experts to really close in on the final version. So finally, now what I'm going to test for these values of 3 through 50 is that the nth Fibonacci number should be really, really close to the n-1 and n-2 value. Why do I have this little fudge factor here? Well, that's not actually this formula is exact, but what's not exact is the floating point representation of these numbers on my computer. So I'll run these tests, and you can see I didn't get any errors. But if I show you what these numbers are for like the 50th value, they're huge. Like this is way bigger than like billions. This might be in the maybe trillions almost. I can't quite. I think that's like 7 trillion. So sooner or later, these numbers start to get really large, and this exact formula, just because it's implemented in floating point numbers, becomes less and less exact. So again, I might add exact formula version of the Fibonacci numbers function. Okay, so I'm feeling like this is really good. Maybe your boss is totally satisfied. The stakeholders are like, okay, I understand computers have limits. Like we won't ask you to compute any more Fibonacci numbers. But what we'd really love is some kind of data visualization. Like the stakeholders, they believe that you're doing great work, but you know, they just want to see a data visualization or something. And so let me add that in. So we might say, you know, we'll need the tidyverse to create a tibble. And then we'll just look at the first 40 numbers. And then one of the features of a tibble is that you can define columns in relation to other columns. So I'm making use of that here. And then I'll make one plot that's this just on the normal scale. So let's see, why did that not? Oh, I'm missing a parentheses. And then I'll make another one that's on the log scale. And you'll see why if I show you the first plot, because actually, let me improve these a little bit. So, you know, I might want the x-axis label to say n, and I might want the y-axis label to say Fibonacci of n. And I'll add those on here too. Okay. So now we have plot 1, and then plot 2 shows us something, you know, essentially evidence that this is growing exponentially. And then I think I'll just add a title, and then another title for this second one. And then I think good practice is probably to break up these so that they're not all on one line. and I'll make a figure and we'll put it in the README, which I think is a good practice to know how to do, because it's really nice if you include figures in the README, because it makes the README more engaging. So we'll use the patchwork package to put the two figures side by side, and then we can save this figure. And then this is kind of a wide figure, so I'm going to make it wide and then height fairly short. And let's just check that this file looks good to me. Okay, that looks fine. So now that this figure is here in my code repository, you'll see, Git is letting me know that I have changes. I'll commit this first. So adding data visualization, I'll commit that. And then for my next commit, I want to use this down at the bottom, or maybe I'll actually put this at the top. So maybe here, I'll put, I spelled that wrong, didn't I? So when you're using Markdown, the syntax for including a image is this exclamation point and then brackets and then open parentheses. I'll fill out what goes in the brackets in a second. So we can put the link to the file name inside the parentheses. And then you're supposed to put alt text. This is really important for accessibility. This is the description text that accompanies the image if you hover over it. And it's what a screen reader reads if somebody is blind and can't see the image or has vision disabilities. So we might put that as our accessibility text. And so I'll commit both of these together and I'll say, add a visualization to the README. And I'll push that. And now if I go back over to GitHub and I go over here, you'll see now my figure is here. And I find that to be like so much more compelling than a wall of text to have your data visualizations included in your repository. So I guess I'll stop there, and I'm happy to answer questions along with Nicole, but I really hope that this was useful. And I think, if you are interested in us covering or having someone else, an expert especially, come in to talk about workflows for collaborating on GitHub, especially with others or in larger teams, we can organize a talk on that. But we really wanted to make sure that we cover these fundamentals, these individual workflows before we got into that so that nobody gets left behind. Thanks, everybody. I'm glad you enjoyed it, Todd. Thanks, Usman. Yeah, of course. We're happy to host.
So I did notice that, oh, sorry.
Yeah.
I was going to say Todd did put a question in the chat. So I can read it out loud if we both want to. Okay.
So what's the best way to work with other developers? Should each developer create their own branch? If so, how should one name these branches? I don't think there's any one best way. The pro Git book that we recommend, and I'll just bring it up, is kind of, it's quite technical, but it does have a section on Git branches, but let me see. Yeah, this distributed workflows section. So they talk about different practices that you can perform. So, it can get pretty complicated. So, I mean, some history is that Git itself was developed to maintain the Linux kernel to give you a sense of just like the kind of complexity that Git supports. And I'm sure that the workflow that they use is complicated to do that. What I like these days are to use like branch names that have the developer's name in them, like typically first name or preferred name, and then like a dash, and then a topic name. So if it's like, you know, like I might put like, you know, Testa, bug fix for ... right? Or something in the branch name. And that way, you know, everybody can kind of just have an intuitive understanding. Or some people will put like a slash, like they'll put like, you know, name and then slash and then what the branch name is for. And then the other best practice that I would suggest that's really important for working with other developers is when you're going to submit pull requests, people on the other side of the pull request love to see that button that says like these merges can be automatically merged, or these changes can be automatically merged, because it just means they don't have to think. And from your perspective as the developer who's trying to get your code pushed into the repository, that really just means you should pull everything from the branch that you're trying to submit a pull request to right before you go to submit a pull request. And then, you know, if there are merge conflicts, resolve those at that point. And that way, then when you submit the pull request, it should just be, you know, there's no issue of are there merge conflicts? It's just an issue of like, is this the quality of code I'll accept into the code base? Or like, does this implement a feature that I want to see? Olivia, yeah, I think, so which OS are you on? I think the Happy Git with R book has some advice about this. Let me, yeah.
I think that it's not set up with a project is actually, I don't think it's like the installation. I think that it's not showing up in RStudio because, so you might have stuff in RStudio that you want to use a Git for and some that you don't. And so you have to let RStudio know that you are going to be using Git with a specific project. I don't know if you want to demo that again, Christian.
Yeah, so like, for example, if I close this project that I made, you'll see that that Git panel doesn't come up here because, you know, my, like, whatever, my home directory here is not a Git repository. And so I don't have that Git set up. But if you're trying to set up a repository, yeah, the instructions for doing that are in Happy Git with R. So I think, you know, yeah, so what you're probably referring to is like if you have an existing project, or you'll need to just make a project if you haven't made like an RStudio project for your work. And then once you do that, you can go in to tools and then project options and Git SVN. So like, I think if I use this Fibonacci example, I can probably delete the Git repository from this and show you what that looks like. So if I delete that Git and then close this and reopen it, I think that will, yeah, see, now I don't have the Git panel, right? And so what I would have to do, and see, like even my terminal is telling me it's not a Git repository. What I would want to do is, and I have to remember if, yeah, I would want to go to this tools and then project options, Git SVN, and then enable Git. I do want to initialize this repository. Yes. Yes, I want to restart RStudio. And see, you'll see here now I have a Git repository, and I would have to sync it up again with this repository. So if I take this URL, I have to do basically what I did in the beginning, which was like git remote add origin, I think this, and then I think, let's see, I wonder, now I'm not quite sure, but in your case, you would be setting up like a new repository to start with Git. So I hope that answers your question. Go back to the chat. Great, okay, good. Yeah, and I cannot recommend enough this Happy Git with R book. This is by Jenny Bryan. She's like a major RStudio and Tidyverse developer, as well as a statistics instructor. And I particularly suggest taking a look at this daily workflows section. Oop, I clicked on the wrong thing. So these useful Git patterns for real life, these can be really useful. Like, you know, I just need to see the past, or I just need to visit the past and stuff like that. Usman, we'll put the recording on our YouTube once I have some time to just upload it and everything. Yeah. All right, any other questions? If not, I think we can wrap up. Yeah, so definitely, you know, email us, let us know, tweet at us if you want a second talk on GitHub, especially around collaboration. We can try and find a guest speaker, or we can do it ourselves. Yeah. All right, thanks everybody.
Thank y'all. Have a good night.
Thank you so much. Bye-bye.